Okay, let's get started. A lot has happened in the last 2 days, so just to give you a recap, Lab 4, you have to convert the user's input to be uppercase. So what did we learn that allows us to convert a character to uppercase? Tuper or to upper, yeah. So use tuper, and that should be all fine. Apparently, there was a lot of issue with the assignment 3 test cases for I don't know why, but the TA said, I have an emergency situation. The test cases need to be redone, and can you extend the deadline? And I said, sure. And so the new test cases are up, and the due date is the 18th. So instead of today, it's due next Monday. To a company for any issues that might arise as a result of that. And assignment 4 is posted. So I looked at the test cases myself of assignment 4 and they seem dubious. So be careful and ask the TAs because they wrote them. Yeah. Yeah.
So if you pass the test cases before and not passing them now, divide your average by 4.0, that should fix that issue with you, because they added decimals so on the test cases now. So just divide by 4.0 and it should fix that issue.
Yeah, so if you're not passing test cases now, whereas you were before, it'll probably be fine if you just submit your old assignment because you were given those test cases and you passed those. So it's wrong to now give you a new standard to go by, even though you passed the one that you were already given. So we'll figure out a good solution. Maybe we'll look at like your score before and after and take the maximum of the two or something like that. So it'll be in your best interest. But any questions about anything? Has anyone looked at the midterm sample? Any other questions about the sample? What did I ask you to do on Monday? Look at the sample. Who has looked at the sample? Any questions about the sample? So everyone does perfect on it. Great. All right. Yeah, go ahead.
The sample's on the midterm one, exam, right?
Oh, sorry?
The sample on the midterm one.
No. So it's in the announcements down here.
Oh, it's in the, okay.
Yeah, so it's here. Any other questions about anything? Yeah.
So would revision of the slides, of course, and the sample, would that prove sufficient practice for the midterm?
Oh, so you're asking like what is a good set of practice things for the midterm? Definitely these questions. So here's a bad idea. To write down verbatim everything from the slides and from the homeworks and from the midterm sample. That's a bad thing to do. Because one, you might not be able to fit everything anyway, but even if you could, then you're not really thinking about what is actually important. What are the important things that I'm trying to ask you here? So if you look at these questions, like this one is, write a complete C++ program. Do you think I'm going to ask you to write a complete C++ program somewhere? On the actual midterm? Yeah, probably. Because, why? Because you have to understand how the include directive works. What does using namespace std, if you're going to use it, do? How the structure of the main function works, and then actually solve a problem. So that actually is part of the problem here. So it's not stated like what's the purpose of the include directive and everything, but that I'm really testing you that in some sense. Like down here for question 2. I have a question about converting binary to decimal and ranges on integers. Or what if we had some arbitrary thing in binary and we did some operation on it? How does it relate to the original? Or what if we did some operation on 2 numbers and can we say something about the result of that? Then we have more questions about can you actually solve this problem? So take a look at this problem. So it says we're going to calculate the GPA of a student. The integers will come in as x and y, where x is the number of credits in the class, and y is the GPA of that class. So if you get an A, you get a 4.0, etc. When the user enters -1 for x, no more input will be presented. What do you think that is asking you to do? What does the -1 you think mean? So the term that we came up with it starts with sen and ends with tinol. Yeah, so this is a sentinel, but think about this. Do I know how many inputs the user is going to be presented? No. So which loop do you think would be best for this scenario? While. So it's not explicitly asked. You're not going to be asked in the midterm, write a while loop that does this, right? Or do a for loop that does this. You're not going to be asked that. You're going to be asked, write code to solve this problem, because that's what this class is about. Principles of programming, which is solving problems. So you're going to be solving problems here. I'm not going to ask you to write a while loop or whatever. And then here's the calculation. So, and then I'll let you work on this, and then we can work on it if you have any questions about it. Yeah, and I can tell you this right away, none of the questions will ask you to prompt the user. So don't prompt the user. There's no need here, because it just wastes time. So if you're writing cout, enter input for this, you're wasting time, okay? You're not going to be asked to do any prompts for the user. And then here's another one which is a little more difficult than the last one, but it emphasizes some of the concepts also. Any other questions about the midterm? Yeah.
Do you want us to write notes like we do in our assignments and labs, like notes of what we're doing? Do you want us to include that instead of copying the user kind of thing?
So should you write notes like you did on your assignments, but on the sheet of notes that you're allowed? I'm guessing that's what you're asking?
Yeah. Do you want us to write notes? Kind of like
Oh. Okay. So my advice is to write what you think is most helpful for you. So if there's some concept that you just can't understand or just can't get, or there was something that you think is important, write that down. Because if it comes up, now it's available for you to actually use. Don't write things that you get right away. So like, you probably don't need to know what an int is, or what cin or cout probably do, right? Because we've encountered that so many times. But maybe something like converting binary to decimal, that might be something you may want to write down. So things that you think would be helpful for you.
I think you meant comments.
Yeah, comments.
Oh, you mean comments in the code? Unless you're going to be doing something really complicated in your code, I wouldn't write comments. Because all of the questions in the midterm, so every solution for the actual midterm, the coding part, has at most 15 lines per question. And some of them actually much less. So the coding questions are not long. And actually I should emphasize some of this. So let's see. Do I have one here? No. So take a look at this question. Write a complete blah, blah, blah that does this. And look at the extra credit down here. It says, say in English what we would change to your program to do blah, 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 blah. Notice how much space I put here. Do you think I'm asking you to write a lot? No. If you're writing like up the side of the margin and on the back side of the page, you're probably writing way too much. So I'm telling you like this amount of space, let's try to zoom out a bit. So this amount of space should be more than sufficient for the question that's being asked. And I try to allocate the right amount of space so that you can answer the question fully. But don't try to be brief in everything you write, because writing more can only hurt you. You can't if you write too much, you may say something that's wrong, and then we have to take points off. Just say what's needed and nothing else. Okay, any other questions? Yeah.
So, because we're not going to be prompting the user,
Mhm.
in the case of something sort of related, like if we had to write in like a CN command, would you just directly go to that with like?
Yeah. Yeah, so if for input wise, just say cin blah blah blah. You don't need to say cout anything. So in fact, there's no reason to write the word cout on the test because it's not needed. Any other questions about the test?
Also, how do you think it's going to be like on timing? Is it something?
So timing wise, how many questions are going to be on the midterm? How many minutes are you allocated? 50. So how many on average per question? 10. So I'm not expecting perfection on everything, on like crossing every D and dotting every I. I'm expecting a 10-minute answer. Okay? So if you're spending 15 minutes on a question and you're still like 2/3 of the way done, you're wasting your time. If you don't quite get the question right away, move on. Get the points that are easy first, and don't worry about the hard ones because every question is weighted the same. So even the hard questions are weighted the same as the easy ones. So get the easy points first. Other questions? Okay, so let's get back into stuff. I mentioned last time that I had an example in my research where I had a 6 Nestle deep for loop. I actually lied. I have 8. So and an if statement to boot. So and each actually one of these for loops is actually necessary. I can't make this any smaller. So it is just to show that. In fact, this program that I wrote yesterday to try to solve a problem in research, every part of it we can read. So if I like gave it to you right now, you can read it and understand, well, maybe not exactly what it's supposed to do, but get a general idea of how it's supposed to go. We're not doing advanced concepts here. So it's pretty interesting that sometimes we just do brute force things like this, where we have like 8 nested deep loops. But anyway, I just wanted to show you that. Okay, let's get back into stuff. So what did we talk about starting last time? The thing on this title slide. Functions. Right? So what is a function? Ah, you can read the slide. So yeah. So the issue that we were faced, it's not really an issue, but it's something that's kind of annoying, is that we were putting all our code inside main, which is fine. There's nothing inherently wrong with that, but it's just a lot harder to maintain. So if we had a block of code that we did a gazillion times, a technical term, then if we needed to ever make a change in one place, then we need to change it in every single one of those instances. So in fact, we're going to use this as a case study to look at the solution for assignment 2. So notice, look at this. So it was the one about the in and out menu thing. So do you notice anything repetitive about this? Yeah, so the only thing that really changes here is the input that we're considering and the string of text that corresponds to the menu item. Literally everything else is exactly the same. So my advice is, if you're doing this at least twice or even once, put it into a function. And so it makes thinking about this a lot easier. And here we're doing it like 10 times, so it's definitely a good reason to use a function here. So we'll see how to fix the program in a bit. So modular programming is the idea that we're taking a giant block of code, maybe in main or anywhere else really, and breaking it up into multiple parts. It's such that each one of the parts themselves solves one task. So like the assignment 2 solution, one piece of it could be handling one menu item. So it takes an arbitrary menu item, double doubles, hamburger, whatever, and handles that input by itself. And then so that the input of one of those that variable can be handled in exactly one place. I don't need to do it multiple times. So it supports this divide and conquer approach. So divide and conquer is a term that's used for something else in computer science, but the idea is that we're breaking it apart and conquering each of the smaller tasks. Instead of conquering the giant tasks, which may be too hard, we're conquering each of the smaller tasks. A function is just basically a piece that does one task. So a module in modular programming, same thing, function or module. Motivation simplifies the process because we only have to think about one thing at a time, and improves maintainability because now we only need to modify it in one place instead of many places. So how do you actually make a function? So there are two things about functions that we'll be saying quite a bit. A function call is when I'm calling a function. But basically, this means that in some place, we're invoking another function to execute. So if we're in the main function right now and we call square root or something, sqrt, we're transferring the control from the main function to the square root function. And then execution is going to happen in the square root function. And when it's done, whatever that is, it's going to transfer control back. So if I'm making a function call, it starts from wherever it is. It transfers control to whatever the function I'm calling. And then when it's done, it comes back to the exact same place I started from, or was before I called the function. So about the function itself, there are four main things of functions. So the name of the function. So like in sqrt case, sqrt is the name of the function. Parameter list. So for the square root function, for example, we want to know the square root of 144, for example. So the argument of square root would be 144. So we can actually look at this. So if we go look up sqrt, C++, and go to here, if it ever loads. Okay, so if we actually look at this, here's the name of the function, and here is the parameter list. So how many parameters are in this list right here? 1. Anyone say 2? I won't go into that, but technically there are 2. But for our purposes, there's exactly 1. So you may think, okay, double and x, those are 2 things, but the way that this is written is that this is not the actual function itself, but something called a prototype that we'll get to later. But basically it tells us the single argument that we are considering is of type double. So the function square root is expecting to receive something of type double. So if I give it 144.0, that's a double. If I feed it 144, that's an int, but ints can be converted to doubles. So anything that's like a numerical type can be passed to square root here. If it said int instead, then it's expecting an int versus a double in general. Okay, so what else? So we covered name and parameter list. Of course, a function can have any number of parameters at once, and we'll see examples of how you can have multiple parameters. The body of the function is just the code inside the function. Nothing interesting, truly interesting there. So like all the code that we've done so far is in the body of the main function. Okay, so main is a function, square root's a function, all of those are functions. And something that we haven't really seen before called a return type. So what this is what type of value is going to be given back when the function is done. So if we look at an example of using square root right here, notice that we're calling square root right here. Param is a double right here. So we're passing a double to square root, which is good. But if we look at the double on the front, that is the return type of square root. So we're feeding square root a double, and it's giving us a double back, whatever that is. In this case, it returns the square root, but it could it be any double, truly just based off of this definition? Could it be any double? Yeah, so as long as we're giving back a double, that's all that's needed. So if we look here, result is also a double. So you see that result equals square root param. The thing that's returned, that's given back from the square root function, is now being assigned to the result variable. So if we're feeding 1024, I don't know what's, oh, okay, 32. I should have known that. So the square root of 1024 is 32. So the square root's going to do its computation, whatever that is, and it's going to say return 32, whatever the return actually means. So it's going to give us back 32. So essentially the right-hand side evaluates to 32, and so result will be assigned 32. Okay, and then we'll print the result down here. So the return type is what is given back when the function is done. So in fact, if we notice, what's the return type of the main function? Int, right? Does main have any parameters in this example? No. There are examples where main does, but in this example, main does not have any parameters. Where's the body of the main function? In the curly brackets, right. So at some point, we got to return or give back an integer value because the return type of main is int. Is there a return anywhere? There is down here. So in fact, this return 0 is abiding by the return type of main. So as long as we're returning some integer, then we're okay. There's a difference with the main function, which I'll talk about now. What if I leave that return 0 out? Is it abiding by the int declaration here? Is it returning anything? No. So there is no return here. So in general, this is going to give us a compilation error. And we can actually see that, and I'm lying. We won't actually see this, but let's see. So let's g++ our main file, and it compiles without errors. Anyone know why? In every other case of functions where we have like an int some function and we don't return, that'll cause an error. But why not here?
Does it defaultly send 0 to the main function?
Yeah. So what happens with the main function, and only the main function does this, is if you leave out the return, then it'll automatically give you a return 0 at the end, no matter what. So only the main function's like this. If I made some other function like f, I just make some arbitrary function f and I don't return anything in it, and we compile, then I'm gonna, well, get a warning. But in general, this is not the good thing to do. So when you have a function and it has a return type like this, and you don't give a value back by returning anything, that is either a compilation error in some cases or a warning at least. So, but not with the main function, because every C++ program that does anything has a main function in it. So they just decided, people leave it at anyway, let's just assume that the main returns 0. But the correct thing to do is to put a return 0 here to say this main function is done. Yeah.
So if it's like a string, would you put return?
Oh, good question. So if I put some some string like this will actually give us a compilation error because the string right here, even though it's not actually a string, but is not convertible to an integer. And so,
The syntax, right?
yes, yeah. So this is actually a syntax error. Yeah, it's a syntax error because the return type of main is always, well, for our purposes, it's an int, and this is not an int. So because they are not the same or not convertible between each other, this will cause an actual error. Yeah.
So whenever the program encounters a return 0, does that mean that it ends the function?
Good question. So let's just say we had a return 0 here, and let's just say we had a different function up here, f, that its only purpose is to return 42. Then what happens, so we'll talk about return in a bit, but to give you a sneak peek, when you encounter the return statement, that function's execution is done. There's no more execution of that function when you encounter a return statement. So it's kind of like the break statement for a for loop. So remember, the break statement for a for loop says, get out of the for loop immediately. The return statement says, get out of the function immediately. It's the same idea. But we'll get to the return statement in a bit. But any other questions on this? Yeah.
So our library is basically functions.
Yeah, so the question is, are libraries just basically functions? And the answer is yes. There is something in the next chapter that'll contradict that, but from everything that we know so far, it's just all functions, yes. There are things called global variables and static variables and classes, and we'll get to all that goodness. But for now, it's just all functions, yes. And so how does an application work then? So you know so far that when you start a program, you start at the main function, and then you may call other functions if you're calling the function. But you always start at the main function. You don't start anywhere else. So a good exam question might be, can you have two main functions in a single program? No, because then it has to decide which main did you actually mean. Did you mean this one or this one? So there can only be one main function per program. But any other questions? Yeah.
What are the brackets?
You mean these?
No, the parentheses.
Oh, the parentheses. So the parentheses here mean to write down the parameter list. So in this case, in F and main's case, do they have any parameter lists? Are there any parameters being passed to F or main? No, because there's nothing in between the parentheses. We'll get to examples in a bit. But if I wanted to pass in an integer to F, I can write an integer x like this. So then I am passing an integer to F. So now F has one parameter in its parameter list. So the parentheses are always required, but you don't have to have any parameters in between the parentheses. So what is a function? So here's just the main example again. Main is the name of the function. There's no parameter list. In this case, it's returning an int, and then the body is the cout statement and the return 0. So this is basically what we just talked about. So we talked about 4 things for functions. So it's the name, the parameter list, and the return type, and the body. The header is the same thing minus the body. Okay? So those 4 things, the name, the parameter list, the body, and the return type. The header, if you take away the body, those 3 things that are remaining, that's the function header. So if you look here, the header is this first line only. So it's int main with the parentheses. So that's the function header of main in this case. Okay, so and there's no semicolon after the parentheses, or at the end of the header in this case. The return type. So return type says, what type of thing are you going to give back? Are you returning an int, or are you returning a double, long, string, whatever? But sometimes you don't want to return anything. Okay? Sometimes you just don't want to return anything. Because if you're like in the case of printing something, well, if you're printing something, you're not giving a value back, you're just printing. So here, there's a special return type, and that's something called void. So void, you gotta put a return type there, but void just means you're not returning anything at all. Okay, you gotta put something there, but if you're not returning anything, just put void. So if you're just gonna be printing stuff, or in general just not giving a value back, then void is a great option for that. So let's actually, do we have examples? No, we don't. Okay, so let's actually make our program more usable or more maintainable. So let's look at this program. So, and let's really think about this. So the thing that we have here is we have these, let's see, 6 lines that are repeated over and over essentially. There's a small difference, but essentially they're doing the same thing. So what are the things that are actually changing in each of the examples? So the thing that I can see that is changing is this text right here in between, right? So it's doubles in this case, cheeseburgers here, hamburgers here. The incorrect amount and return 0 are exactly the same thing, right? None of that actually changes. The other change is the variable that's involved. So in this case, it's DD burger, then C burger, then H burger. So there are really 2 changes that we have here. It's the string of text that corresponds to the item that we're considering, and the variable that we're considering. So if we're going to make a function that handles one item at a time, how many arguments do you think it should have? How many parameters? If we have 2 things that are changing every time, we should have 2 arguments. Because everything else is exactly the same. The thing that should change are the things in the parameters. And since we have 2 things that are changing, we should have 2 parameters. Well, let's see. Let's actually just copy and paste this into a function. So let's make a function. I'm going to have it return an int, and we'll see why in a bit. So let's just, so what is a good name for a function like this to handle one menu item?
Single menu item?
Yeah, or handle one item. Let's just do handle single item. So how many parameters does it have right now? 0. So we got to have 2 parameters here. Well, we got to say what are the types of the parameters that we're passing in. So what is the type of the text here that we want to pass in? A string. So let's have one argument be the string. So what should be the variable? So we're free to actually use the brand new variable name here. So we're free to use a variable name. What could be a good variable name for this? Food item or item name. So let's just do food name as the name of the item. And I guess we haven't covered this yet. If you want to have multiple parameters, you separate them by commas. So like with loops where we had the comma to do multiple things at once, it's similar here where you have a comma in between 2 different parameters. Okay, well, we're handling this right now. That's good. Well, what about this? So we got to pass in the item that's going to actually get the amount that's given by the user. So what is the type of all these variables that are used here? Int. So the second parameter here should have what type? Int. So what would be a good name for this? Maybe like food amount or something. This will actually cause us a problem in a little bit, and we'll see why. So a little foreshadowing. All right, so let's copy and paste this in, and then let's see. So the thing that's changing is, well, we don't want double doubles here. What do we want to be in place of that text? The food name, the thing that we're passing in. So can I just write this? No, what does this do? It prints food underscore name, not the text that was passed in. So what do I need to do to fix this? Yeah, close this, actually print the variable itself, and then continue the actual text here. And do we want DD burger here? No, what do we want instead? Food amount, good. So that's good. And then, so the great thing now is that we can reduce all this code to, so what did I call it? I called it handle single item. So handle single item, double doubles, and then DD burger. And so all of that 6 lines reduces to this. Isn't that really cool? So isn't that a lot easier to do? Here's the issue. So I gotta throw a wrench in there somehow. So let's see. I said before that we're free to actually use these variable names here, right? I can use a brand new variable name here. Question for you. When I consider this text double doubles, and I look at the food name over here, are they the same location in memory? It turns out no. So what actually happens, and I guess we'll get to this in a bit, is when you call a function, if we're just doing things like this, there's a way around it. But if we're just doing things normally like this, it creates an independent copy of that variable. So the string and the integer that we passed in, they are independent variables from the original one. So this DD burger right here, that was declared in the main function, and the food amount variable right here are independent locations in memory. They're not the same variable. There's a way around this, but we won't get that until like a month from now. So the issue here is that we're CNing into a brand new location in memory over here, but the thing we want to modify is over here. So when I continue this execution after I call this function, then the original variable hasn't been changed, unfortunately. So what could we do to fix this? Well, consider the double doubles for a second. Do I care that food name has a different value? I mean, a different location in memory? Do I care about that? No, because all we're doing is just scouting it. I don't care that it's a different location, but food amount, I do care. So I don't want to make an independent copy. So in fact, I'm going to remove that variable from the parameter list. That's why I said that there was a problem. What we're going to do instead is, well, I can't have this here. Notice that I put int on the handle single item. What could we do to instead to give back the value that was returned to the main function and assign it to the DD burger variable? What could I do instead? So I'll tell you. What we can do instead is make a variable in here, cin it here, and then return it here. So here what we're doing is, suppose they enter 42 double doubles, have mercy. Then what's going to happen is 42 is going to be returned from the handle single item function back into main. Well, looking at this function call right here, is it going to be assigned to anything? As is right here. No, it's not assigned to anything. So when I do this, the value is just going to be thrown away. It's not going to be assigned to anything. What variable in here do I want to assign it to? DD Burger. So I'm going to assign to DD Burger. And so now, let's follow the execution. So we come into main function, we do stuff, create variables and whatnot, and then immediately go into the handle single item function. So, and we pass double doubles in. So we come into here, food name has the string double doubles in it. We create this food amount variable. I don't know what value it has necessarily. I see out how many double doubles do you want to order. We enter that amount. So let's just say 42. 42 is a good value, so will I go into this? No. And actually there's an error here. We'll get to that in a second. So then 42 is returned from the handle single item function. What happens now? 42 is returned. Where does execution restart from? Back in the main function. And where in the main function? Where I left off. And where I left off is precisely right here. So this handle single item function has the value 42 to be assigned to something, which is DD Burger in this case. So to recap, 42 is entered up here, it's returned 42, and then now it's assigned back to DD Burger. What if I wanted to do the same thing for cheeseburgers? Guide me through the process. Yeah, so it would be instead C burger equals what? Handle single item, cheeseburgers. And then I can do the exact same thing for all these, right? I can do the same thing for all of them. No issue there. Here's the problem. Anyone see the problem with this return 0? Before, when we had everything in the main function, what did this return 0 do? Yeah, so return 0 effectively quit the program. What does it do now? It just quits the function and resumes back in main. So there's a concept of being able to quit a function from anywhere, but we are not there yet. If you're curious, look at the end of the function slides. There's something called an exit function. But does anyone have any questions on why this is so much better than programming the old way? Yeah.
What if you actually want to return a value 0?
Yeah, so if you wanted to return the value 0, like here, you can just return 0 like this. Like if I wanted to give back the value 0, this is the way to do it. If you want to return an actual value, just say return the value that you want. But if you want to quit the program, because that's what this was effectively doing before, you have to do something else. Yeah.
In this case, whenever they enter a negative number for like double doubles or whatever the food amount is, it would say incorrect amount, right? And then it would return 0. So in the main function, it would keep on going as if they entered 0, right?
Exactly.
So that's not necessarily bad, right? Because then if they enter a negative amount, it's just like, oh, you want 0.
Yeah, so that's actually a really important question in software engineering. So the question was, well, if they enter a negative number, you're returning 0 anyway, and so the result at the end effectively isn't going to change because the receipt's going to print 0, and that doesn't affect the cost anyway. But the issue is, well, what if they enter something that could mess up code later? In this case, it's okay. But we want to have code that is correct to a standard. So a standard here is, in this particular case, could be all inputs are at least 0. Every input is at least 0. And so if anything is entered that is not 0, that is not valid. We could amend this standard to say, well, if they did enter something wrong, just clamp it to 0, and then just, if it's negative, just put it up to 0, but it depends on what the standard actually is that we're abiding by. In this case, we're saying that negative things are not good, but it depends on what you're actually programming for. In this case, it doesn't actually change the amount that they're paying, but it's just now that you have to really think about this, whether this 0 is okay or not. So, and then if you have a more complex system, you have to reason about that even more. In this case, there's only one function other than main, so there's not really an issue. But in general, you have to really worry about that sort of thing. Yeah.
What's the purpose of the parameter?
So what is the purpose of the parameter here? Is to be able to pass in any string. So I can adapt this handle single item function to say how many anything do you want to order. So if I want to like amend this menu, I can just add another line right here, handle single item fruit or whatever. So I can have this function adapt to whatever input that I want. So here I have double doubles and cheeseburgers so far, but I can add as many things as I want. And the only cost to me really is to add one more line of code to actually call that function. So it's adapting to however I want it to work. But here's a question for you. Could we have just done away with this handle single item function and just put everything into the main function? Yeah, so functions aren't actually necessary in the sense that we could still do it in principle, but it's clearly much better than doing it the old way. Any other questions about this sort of thing? Okay, let's see. So let's do one more slide. So if you want to call a function, you do this. So you use the function name followed by parentheses. This is not really correct because you need to put the parameter list inside. But other than that, you do need the parentheses, that's always required, and semicolon because it's just a function call at that point. When a function is called, the program executes the body of the function. So it stops from wherever it is and it jumps to the start of the other function. But the interesting thing is that now we can have functions call other functions. So in some cases, you may have a function A that calls function B, and B also calls function A. So you can have functions call other functions. It's a function party. Yeah.
Wait, can a function call zero?
Yes.
Really?
Yes. And this is something that's really wacky. So in fact, what you can do sometimes is you can call handle single item as many times as you want. So I can have functions call other functions. Really, really weird. So this is something that's sometimes called recursion. So if I have a general thing I want to solve, and it's expressed in terms of calling the same function on a smaller instance of that problem, then I can call the same function with a different input. So here what I'm doing is, when I call this function, it's going to zoom down into handle single item, and then it's going to call itself again. And then what happens is that we have the main over here, it calls handle item, then handle item calls handle item again. Then what could happen is this second one will stop, and then it resumes execution back from the original function that called it. So it just backs up one in the call stack, as it's called. So you start from main, you call something, call something, call something, call something, and then you eventually stop, then you work your way back. Or maybe go forward or come back. It depends on what you're actually doing. Here, what's going to happen is you're going to keep going down the chain. So you're going to keep calling handle single item over and over and over and over. Yeah.
I just wonder if you could like make a loop by calling this
Yeah.
original function.
Yeah. So, so the question is, can you make a loop by doing this? And the answer is yes. Yeah. So if you remember the example where we printed from 5 down to 0, we can make a function that calls itself with the original input minus 1. And then it just keeps going down until we stop. Any other questions? Technically, no in this case because we have a C in here. So we could stop at some point. But if we left that out, then yes, it would be. What? Yeah, so you can have if statements inside here. Yeah. So I'll see you all on Friday.